Welcome back to Cradle to Grave R. Today we're going to test the waters with some C++ programming. I know, this is an R channel, but this might be a way to segue into some C++ as well. Because in R, when you are dealing with large data sets and complex calculations on that data, or simulations, or anything that might need to be scaled, C++ is probably going to be your answer. And so I want to teach you in this video how to interface using a function called cppFunction using the RCpp package. I'm going to walk you through the most basic example, and then in the next episode I'll show you how to keep your C++ code separate from your R code to make it much easier to deal with using a separate IDE. Before we begin, I want to mention C++ compilers. If you're on a Mac OS, I don't think you need one because it's running off the Unix system, which comes with GCC, which is a compiler for C++ programming. For Microsoft Windows, Microsoft Visual Studio comes with the compiler, or will be your compiler. So you might need to download a compiler. Don't let that fool you. If it sounds complicated, just Google, how do I download a C++ compiler? I think everything else should be automatic once it's installed. I'm not going to go into the details because I am using a Mac. So anyways, we want to install the RCpp package. So just click on install and then RCpp. And once that's installed, we can then use it. Okay, that shouldn't take long at all, especially if you already have the compiler. Now let's load that library into our script. And it's just loaded like that. What we're going to do is we're going to create a single function in R, and then we'll duplicate that function in C++, and then we'll run benchmarks to see which one's faster. So the function we're going to use is a squaring function. We're going to square a vector of numbers, so a list of numbers basically, right? So let's start by creating that function. So this is all from memory. It's been a while, as you know. I haven't been on this channel in a while, but let's just create the function called sum of squares, and we'll make that into a function that takes in a variable x. And of course the code for that should simply be, what we want to do is return the sum of squares, so we'll use the sum function. Now remember, in R you're summing the entire vector, and that's the beauty of R, is you don't have to iterate through most of the vectors to get access to the data within it. So we'll just sum x squared. So again, in R, don't forget what's going on here. Now this is strange for me because I'm used to more C++ from back in the day, 25 years ago. But the sum of squares takes a function and whatever x value is, but x is a vector in this case. Of course, it's not really defined yet, but x is a vector, and so that vector is going to be, each element will be squared and then summed, and that's what this is doing. So that is the function for R. I'm going to actually just go ahead and load that in by Command Enter. And then now we'll do a cpp function. CPP, you'll see it auto-populate. CPP function, now in single quotes, we're going to put our C++ programming in there. There's going to be no auto-populate, no error correction, nothing to help us, right? So we have to do this from memory right now. In the next episode, I'll show you how to use a different IDE and make this a lot easier and separate the C++ code completely from the R code. We'll do that in the next section though. So we want to have a function that returns a double, so double sum of squares, CPP. So we can distinguish the two functions apart. We can't have the same function name, I'm pretty certain anyways. And that will take in a numeric vector as an input, x. And of course we'll create this function. And we're going to need, because C++ doesn't really do all the summations inherently, we're going to have to do that manually. So we'll have to have some sort of total. We're going to say double. Oh, excuse me, I should not have closed that. There we go. And close that function. Make sure you see what I did here. The quotes are actually for all of the C++ code. And then I ended the function with the end parenthesis here. So double sum of squares, bringing in a numeric vector x. Now we need a total count, so double total. We'll set that equal to 0. We'll equalize it, or initialize it, I should say. Semicolon, because it's C++. In C++ version 23, which I'm learning right now, I just started yesterday, they don't initialize this way. They actually initialize, let me just show you. Just because I'm going to start learning C++ 23, so I want to at least give you some of what I've known or what I've learned. So it'd be double total, and then you would actually use the curly brackets and put a 0 in there. Even though this is C++, there's different versions of C++, so I would like to use version 23 when possible, but most of the compilers aren't up to date yet with that. So this initializer isn't quite what you're supposed to do. There's another way to do it with curly braces, but we'll get into that later down the road. So my total is equal to 0, and then I'm also going to need to figure out what the size of that x is because I have to manually iterate through that. So we're just going to say integer size is equal to x.size, because if x is a numeric vector, it'll have a function called size that you can call, and it returns the size of the function. So that should work. Semicolon, don't forget semicolon. Now we'll do a for loop for integer I is equal to 0. I is less than size. Yeah, less than size. I plus plus. So iterate through and then iterate what? Well, everything inside these brackets or curly braces. We're going to say total plus equals, so that means total equals total plus the x sub I, and we have to square that. So I'm going to be careful and just put this in parentheses there. Yes. So that's what the total equals, and we will return the total at the end of that for loop. Okay, I'm going to execute this function and see if there's any errors that I could think of. One occurred built-in shared library. How is this possible? Let's try, instead of squaring it like that, let's just multiply them together, because that could be the problem. There's subtle syntax errors out here that just kill you. Try that. Oh, no error. Okay, so it was basically if I tried to square that, for some reason it didn't work. There's probably some underlying reason I'm just not sure of, but that worked. So now we can use these functions, I hope. So let's just create some random numbers. We will say our number, well, we'll call it x. In R, we're in the R now, we're not in the cpp function. So x is going to be equal to, we're going to use this function called system.time. So whatever we put in here, it'll tell us how long it took to do that. So we're going to first run, first we'll set x equals to, x is equal to some random normal distribution number, etc., from 1 to 10 million, I think that is. So let's just do that. And then we'll run the system.time, and we'll just actually call these functions. So the first one we'll call is sum of squares, and we'll bring in our x. And I'll execute it right now, Command Enter, and you'll see in my terminal down below, it says 0.086 seconds. Let's run that a couple more times just to see. See, the first time it always takes longer, I'd notice. But now it's around that 0.024 benchmark right here, 0.024, so we get an idea of what it is. We'll do the same thing with the C++ function now. So we'll do system.time, and we'll call sum of squares, but the other one, cpp, as it's offered here, and we'll bring in x. All right, we're going to run it once, 0.01 seconds. Let's run it some more, 0.013, 0.012, 0.012. So as you can tell, as I hope you can tell, that it is faster. Imagine you had billions of calculations, how quickly this will add up in time. So when you're worried about time crunches or efficiency, C++ is the way to go. Now we're nowhere near needing this stuff, but I think it's important to show you that it's possible, and maybe it'll help motivate you to say, hey, I want to jump into maybe the world of becoming more efficient with these algorithms. Like I could do it in R, but I could save time in C++. Think about your actual work where you're going through billions of data points. Maybe you do that hundreds of times per hour. So if you can save and squeeze some time out of that, and response time to users, because it's in C++, it helps. When you click the button, you don't want to wait. You don't want to be delayed. You don't want to be casually just waiting for the response. Let it be done as fast as possible. Of course, what if we're doing very complex calculations where matrix algebra, cross products of billions of rows of data. That would take a lot of time. So C++ is where it's at. That's why I wanted to show it to you. Again, next session, we're gonna take this C++ function out, run it in some other IDE, an integrated development environment, and separate the C++ from the R, but still use it. Hope this was helpful. I know it's a lot to handle in one, and I'm a little scatterbrained because it's all new to me, but I'm back at it, and I'll see you guys next time.